So we'll just take one more look at a system of equations here, and I'll start, as always, by numbering them. I am assuming each time that there's no solution. So obviously the first step you would do is plug this in to your calculator and try and get an answer. The other thing to notice is there's no y there, so that's like having 0 y's. So you just put that in as 0 in your calculator. So anyway, I'm going to have a look at this and see what I can do. I'm going to try and combine, I think, planes 1 and 3 and just remove the y. That seems to be the easiest, one of the easiest ones to do, maybe. I think so. We'll try that one. So if I go 4 is equal to 1 minus 3, I'll get 5x plus 4x. I'll get 9x. The y's will disappear. 3z minus, so it becomes 6z is negative 13. Now, can now proceed on and calculate. So actually, this is where planes 1 and 3 meet. So we can now work out where, say, planes 2 and 3 or 1 and 2 could meet. But before we do that, have a quick look at the system of equation, and hopefully what you'd see is that this line we've just found appears to be parallel to plane 2. And so we're just going to check that, because you notice neither of them have y's in them, and the coefficients are in the same proportion. They're both like in a 3:2 ratio there. So we're just going to check and see whether they're parallel or are they the same thing. So I'm actually going to combine those two. So I'm going to take equation 4 and just take away 3 lots of equation 2. So 9x minus 9x is 0, 6z minus 6z is 0, and negative 13 minus 27 is negative 40. So we get a false statement. So therefore, we know that the line of intersection, so that's the line of intersection of 1 and 3, is parallel to the plane 2. To plane 2. And if you think about what that means, we've got two, I'll do a really terrible drawing here. We've got two planes and they meet at this line right here. That line, so it goes off and forever, is actually parallel to another plane. So wherever I draw that plane, I'll draw it down the bottom here, it must be parallel to that line, which forms that nice handy-dandy tent shape. Now, that's the easiest way to spot this tent shape situation. The other way, of course, is to find all 3 lines. I'll draw them as dots here, but those are the lines where our planes intersect. If you found all 3 of them, you would see that they were all parallel. Now, obviously, that takes a little bit more work to do. So if you get into one of these situations, do have a look and see if the line you find happens to be parallel to one of the other planes. And that will generally happen if you get a situation like we've got up here in equation 2, where there is a variable missing.